Hey you guys, so this is part 2 of series, okay? With your FRQs. So in the last video, we went over pretty much the most common question that can appear on your series question, which is finding an X amount of terms and the general term of your series, in which we talked about either building it and then stacking it or creating it from scratch, okay? This next one here is pretty straightforward. So make sure that you guys are using a different highlight. If you take a look down here, I kind of erased everything else. So you want to make sure that you're doing these on a separate sheet so that you have a lot of space, okay? So the second most common question is finding the interval or radius of convergence. There are a variety of ways that they can phrase this question, but it's not that bad, okay? And again, it doesn't appear as often as number 1, but it does appear enough for you guys to want to practice, okay? And also because this can earn you a lot of points. Usually with interval and radius of convergence, they'll offer you about 4 to 5 points out of 9, okay? So just keep that in mind. All right, here we go. So we're looking for any indication of the interval or the radius of convergence here, okay? I don't see any here. Okay, in 2016, part B, it mentions the radius of convergence, and then they ask you to find the interval of convergence. Okay, so we're just highlighting now. 2015, if we skim through this, this one is sneaky. This one here is actually in part A. Use the ratio test to find R, but if you notice, R is defined as the radius of convergence, so a little bit sneaky there, all right? Same thing here in 2014, find the value of R, where R is the radius of convergence. So try to get familiar with how they might phrase it, okay? I don't see any here in 2013. In part A, 2012, there you go. Use the ratio test to determine the interval of convergence. I don't see any in 2011, 2010. I don't see any here. 2009. There you go. Use the ratio test to find the interval of convergence. All right. 2008. Wait. Yeah, there's none in 2008. And 2007, let's see. I don't see any here. So it does appear often, but not as often as finding the first 4 non-zero terms, right? Okay. So here we go. I'll show you how to do. So let's see, we have 1, 2, 3, 4, 5. So I'll probably do around 3 of them, or maybe 2. We'll see how this goes. Okay, so we'll go in order. 2016. So remember, they're either going to ask you for the radius of convergence or the interval of convergence. Okay, radius is definitely shorter. Interval of convergence, you got to do a little bit of extra work, okay? But both are easy if you remember the steps. So here we go. The Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence. So here, if you really understand how it works, okay, you could either do this the long way or the shorter way. The shorter way is assuming that you understand what it really means, what the interval of convergence is. So here, it's stating that when the series is centered at x equals 1, it has a radius of convergence of 2. So I'm going to draw your number line here, okay? If you're centered at 1, you're going to go 2 units out this way and 2 units out that way. okay? So you would be going as far out as 3 and to -1 if you're pushing 2 units to the right and 2 units left, okay? So this is your interval of convergence right here. This is your interior, -1 and to 3. But if you guys remember, after your ratio test, you guys have to check the endpoints, okay? So this is just the interior. You don't have to write it, but it's just for notes, okay? So what you have to do is you have to check what happens when x equals -1, and we have to check what happens when x equals 3. Again, I recommend you guys doing this on a separate sheet, okay? So we have our equation. I should have jotted it down here. Let me see if I can retrieve it. The general term from part A was -1 to the n minus 1 quantity factorial all over 2 to the n, x minus 1 to the n over n factorial. Okay, that was the general term there. So what we're going to do is we're going to plug in what happens when x is equal to -1 and what happens when x is equal to 3. Okay, so here we go. We're going to have -1 to the n minus 1 factorial, -1 minus 1, which is -2 to the n, all over 2 to the n times n factorial. Similarly, we're going to do the same thing here. -1 to the n minus 1 quantity factorial. 3 minus 1 is 2 to the n, all over 2 to the n times n factorial. So this is our summation here, okay? Okay. So let's start off with this over here on the right. 2 to the n over 2 to the n goes away. Okay? So now we have -1 to the n. Now we have n minus 1 factorial all over n factorial. Okay? So remember, n factorial, when you're dealing with factorials, you're trying to reduce it here, okay? And since n factorial is larger than n minus 1 factorial, we're going to play with the larger one here. So n factorial is actually n times n minus 1 factorial. Look back at that video if you need to, okay? So I stopped there because now I noticed that I could actually reduce out the n minus 1 factorials, okay? So I'm left with -1 to the n times 1 over n, okay? Or all over n if you wanted to. So you're going to run your test based on what you see here. Some people would probably use the alternating series test because there's an alternating part here. So you could either use the alternating series test or recognize that this is an alternating harmonic. Okay? But either test you run, you should be able to conclude that this will converge. Okay? We should know that alternating harmonics converge and harmonics diverge. Or using the alternating series test where you take the limit of the non-alternating part. And since it goes to 0, you know it's going to converge, okay? So here, I know that I'm going to include my 3. Okay? We'll do the same thing here. Now, if you take a look at -1 to the n and -2 to the n, they both share the same power. So what you can do is multiply those two together. -1 times -2 is just +2 to the n power. Everything else remains the same. And again, feel free to pause and replay wherever you need to. I am on standby here, so you can text me as well. Here I noticed that 2 to the n reduces out. And same logic here, n minus 1 factorial. N factorial down below is the same thing as n times n minus 1 factorial, because it's always going to be 1 less. That's going to reduce out. And you're left with the summation of 1 over n. And you should know by now that that's harmonic. Okay? Or you can use p-series. All right? But you should know that it diverges. So we don't include it. Therefore, it's open, -1, 3 bracket. Okay? So this one was a little bit shorter in that they told us what the radius of convergence is. Sometimes they don't. So then we're going to have to do the long method there, okay? So there you have it. Let's do 2015 now, okay? Okay, so in 2015, they specifically tell you to use the ratio test to find R. And R is the radius of convergence. So they're asking us to just find the radius of convergence. It's a little bit shorter. Okay? So if you remember the ratio test, we take the limit as n goes to infinity of the absolute value. Okay? I can't stress that enough. A lot of people forget the absolute value. If you forget the absolute value, you're not going to have an interval. Okay? It's needed. So it's going to be, here's a refresher, it's going to be the a sub n plus 1 term. So here's your general term right here in blue. All right. So it's going to be -3 to the n plus 1 minus 1 times x to the n plus 1 all over n plus 1. And we're going to divide that by the a sub n term, which is just what it was originally. Okay? Now, how do you divide fractions? You multiply by the reciprocal. So I'll write it out for you guys. Some of you are comfortable jumping straight to that step, and that's fine too. The limit as n goes to infinity of the absolute value of -3 to the n. Right there, the plus 1 and the minus 1 cancels out, so it's just -3 to the n times x to the n plus 1 all over n plus 1 times the reciprocal n over -3 to the n minus 1 times x to the n. Don't forget your absolute value bars, okay? All right, this is where magical things happen. Not really. Things cancel out, okay? X to the n plus 1 is the same thing as x to the n times x to the first. -3 to the n minus 1 is the same thing as -3 to the n times -3 to the -1. Okay? And again, you don't have to write out this step. I'm doing it so that you guys can see what cancels out. So I notice that x to the n and x to the n goes away. -3 quantity to the n will cancel out as well. Okay? Anything that has nothing to do with n will pop outside of the limit. So we have x to the first. Actually, I'll just do x. Well, I'll simplify it after. Over -3 to the -1. Okay? We'll go outside. Now, you could keep that -3 to -1 on the inside. It really doesn't matter because your end result will still be the same. Okay? We're taking the limit as n goes to infinity of n over n plus 1. Okay? Now, this is your ratio test. We want it to converge, so you always make it less than 1. All right? This limit right here Press play whenever you're ready. Think about what that limit is. That limit should come out to 1. Okay, if you're not sure why, ask. Okay, so then we have all this. I'll just bring that down. All right, so anything times 1 is just itself. So here, the absolute value of x, okay? Now down here, -3 to -1, since there's a negative exponent, it actually goes back up to the top. So you'll have the absolute value of -3 at the top. Okay? Make sure you understand that before you move on, okay? Since there's a negative exponent in the denominator, it moves back up to the numerator, okay? And the absolute value of -3 is just 3. Okay? And our job right now is to isolate the absolute value. So we're going to go ahead and divide by 3 on both sides. So the absolute value of x is less than 1/3. What do we just find here, right? When you isolate your absolute value, take a look at that. That r is that value on the side here. So this has a radius of 1/3. Okay? Now, you're pretty much done there, but just to really drive it home here, okay? This is your answer and you're done, but just for more context. So what this is saying is you're centered at 0 with the radius of 1/3. So you're going 1/3 to the right and 1/3 to the left. Okay? Whenever it's just the absolute value of x, it's centered at 0. Okay? So for instance, if you have the absolute value of x minus 1 is less than 6, that's saying that it's centered at 1, and you're pushing out 6 units to the right, which is 7, and 6 units to the left, which is -5. Okay? That'll at least give you your interior. But again, here they didn't ask you for the interval of convergence, so pretty much all you need is the radius, which is 1/3. All right? And that's it. 2014 I'll leave for you guys to do, because it's very similar. But I want to do one more for you guys. Right here. Okay. So this is pretty much where you have to do the whole thing. All right? Use the ratio test to determine the interval of convergence, not the radius. So we're going to have to do the whole process. So here we go. We take the limit as n goes to infinity of the absolute value of your general term plus 1. Okay, so -1 to the n plus 1, x to the 2 times n plus 1 plus 1, all over 2 times the quantity n plus 1 plus 3. If you notice, I replaced every n with the n plus 1. Don't try to do anything in your head here. Write it out first, all right? Because then you might miss some of the distributive steps there, okay? So that's a sub n plus 1 divided by a sub n. Or you could just multiply by the reciprocal, which is 2n plus 3, all over -1 to the n, x to the 2n plus 1. Okay, so we know we're taking the absolute values, so you can save yourselves a couple of steps by just getting rid of the alternating parts, because if you take the absolute values of it, it's going to turn positive, okay? So even if there's like an extra -1 here, you guys, it still goes away. So I just want you guys to keep that in mind. All right? Okay, so what I'm going to do here before we move on is I'm going to simplify it so you guys can see it. Up here is 2n plus 2 plus the 1. So that's 2n plus 3. So that's x to the 2n times x to the 3rd. And I'm writing it like that so I can reduce later, okay? Down below here, I have 2n plus 2 plus the 3, which is 2n plus 5. Okay, same thing down here. That's x to the 2n times x to the first. Okay, here we go. X to the 2n goes away. You have x cubed and x to the first at the bottom. So if we reduce that, there's going to be 2 left here. All right. Okay, so we're going to get this guy to converge less than 1. X squared has nothing to do with the limit, so we'll take that out with the absolute values. All that's left is 2n plus 3 all over 2n plus 5 less than 1. All right. This limit here should come out to 1. So remember, when n gets really large, the constants become insignificant, okay? So that's going to come out to 1, and we're going to be left with the absolute value of x squared times 1 is less than 1, okay? The absolute value of x squared is less than 1 here. This is where it gets a little weird, all right? Okay, so I talked about this in a previous video. X squared, let's say it equals 9 here. If I asked you guys to solve, you guys would square root both sides. That's what you guys were taught. And then all of a sudden, you get plus or minus 3, okay? The step that's always skipped is this, okay? What really happens when you square root is you end up with an absolute value of x that's equal to 3. And from there, the absolute value will yield a plus or minus, okay? So here, what's really happening is when you square root, you get an absolute value again. So this is really, when you square root, this is really still the absolute value of x is less than 1. And from there, you split, okay? Now, before I move on, here's what a lot of people will do and where they will get confused, okay? They'll first create their compound, then they'll square root, don't write this down, and then they're like, wait, I can't square root a negative, and then they think it's no solution, okay? It's a little bit more detailed than that, simply because of this idea here. It turns into an absolute value first, and then it'll yield that plus or minus, okay? So just watch out for that. It's a really minor detail. I don't think it pops up too often, but it's enough for you guys to be mindful of it, okay? So here, the absolute value of x is less than 1, since we square rooted both sides. Then we're going to create a compound, okay? If you don't have absolute values from the very beginning, you can't create a compound, because that's the whole point, all right? Okay, so that would probably earn you 1, 2, 3 points already, okay? You would probably get a point for setting up your limit, for evaluating your limit, and then creating a compound. Okay, that's 3 points out of 9 already, okay? Let's keep going. Now we have to check our endpoints. So we have to check what happens when x is negative 1 and when x is 1. Okay, so you go back to your general term. It's going to look like the summation of negative 1 to the n of negative 1 to the 2n plus 1. Let me move this. Okay, all over 2n plus 3. Okay, over here you're going to have negative 1 to the n, 1 to the 2n plus 1, all over 2n plus 3. I'm running out of space here, but I want to squeeze it in there. Okay. Let's start off with the right-hand side here, okay? 1 to the 2n plus 1. 1 to the any power is just 1, so I'm going to get rid of that. So here I have negative 1 to the n all over 2n plus 3. okay? Right there, I would use the alternating series test, okay, because there's an alternating piece. So I would take the limit as n goes to infinity of 1 over 2n plus 3. You're going to take the limit of everything except the alternating piece. That definitely comes out to 0, therefore you know it converges by AST. You could have also said that this was an alternating harmonic. That works too. But some people tend to flip out because of the 2 and the 3. Okay? So if you guys haven't noticed already, you have to be very well versed with all of the tests for convergence. You have to know when to use p-series, geo-series, divergence tests, alternating series, comparisons, okay, or the ratio test. You got to be really quick with that, okay? All right, here, since we have the same base of -1, we can add our exponents. So that's -1 to the n plus 2n plus 1, which gives us 3n plus 1. Okay? All over 2n plus 3. Okay, so what do we do here? Right? Okay, think about that. Pause if you need to. What test would you run? How would you do it? Okay, so what you guys have to keep in mind is you got to make sure that that -1 is really alternating your series. So you just quickly check it, okay? If, let's say, n was 0, okay? If n was 0, just sidebar here, if n was 0, you would have -1 to the first power all over 3. So we know it's going to come out negative. So I'll write a little negative there, okay? Now, if n was 1, you would have -1 to the 4th. -1 to the 4th comes out positive, so you know it's going to come out positive. Okay, let's try one more. If n was 2, you would get -1 to the 7th power, which comes out negative. So it actually does alternate. Sometimes it doesn't. Okay? Cool. So we're going to do the same thing. We're going to run the alternating series test because we have an alternating part. So since this mimics the other one, not always, we could say that it converges as well by AST. So what this tells us is we will include -1 and we will include 1. So you put this guy in there. If you're comfortable with inequality notation, you can leave it like that, or you could write it like this, which is what I prefer. All right. Okay, so you've been given several examples here, 3 of them. There's really not a lot of variety to it. Okay, so try the other 2 and let me know how you guys do. All right.